Hi, and thanks for tuning in for the first episode of JBL Car Audio's What the In this episode, we'll explore what's possible if we build an amplifier that's capable of delivering either high current or high voltage. Since power is the product of voltage and current, there are two distinct ways to provide the power necessary to drive woofers. Currently, the most popular way to deliver that power is to use low impedance woofers connected to a high current amplifier. The disadvantage in delivering power that way is that woofers designed to handle all that current must use voice coils wound with heavy gauge copper wire so they don't burn up. The additional mass in those coils raises the mass of the entire moving assembly and makes the speaker inefficient. It's kind of like pulling a trailer full of cinder blocks behind a sports car. There has to be a better way. What if we were to provide a bunch of voltage to the speaker? Then we could use a higher impedance coil wound with much lighter wire. Less mass would make a more efficient speaker. The last time I checked, DB Drag Racing wasn't giving points for extracting a bunch of current from amplifiers, and they didn't give a trophy to the competitor who blew up the most woofers. Remember, when you buy a subwoofer system, the idea is to get a lot of bass, not just to use a lot of power. Thanks to a patented circuit invented by Crown, these new JBL Power Series subwoofer amplifiers can provide both high current for conventional systems or high voltage to drive more efficient, higher impedance woofers like JBL's GTI series or low impedance woofers with their coils connected in series rather than in parallel. A conventional high current 2200 watt amplifier would have to deliver only 45 volts in order to make 2200 watts into a 1 ohm load. That's no problem, but it would also have to deliver 45 amps of current. It takes a lot of heavy gauge copper in a voice coil to handle that much current. With an amplifier capable of delivering 120 volts, we'd only have 18 amps of current flowing, and we could use a speaker with a much lighter coil and have a much more efficient and reliable system. What we have here is a BPX 2200.1 connected to a standard car battery and a power supply, which we'll use to keep the battery charged. Common household appliances and power tools that are designed to be plugged into the wall run on 120 volts AC at 60 Hz. That makes it convenient for us to demonstrate the voltage that this amp can provide. We'll connect an extension cord to the amplifier's speaker outputs and use a voltmeter to monitor the amp's output. If all goes well, we should be able to drive an appliance or a power tool up to about 3 horsepower since we have a little over 2200 watts available. We'll connect a computer with a frequency generator and an oscilloscope to the signal inputs of the amplifier so we can monitor the 60 Hz sine wave we'll send to the amp. Notice that without a signal, the voltmeter reads 8 millivolts or so. That's essentially no output. Next, we'll start the frequency generator, which will send the 60 Hz signal to the amplifier. We now have 131 volts at the output of the amplifier connected to the extension cord where we'll plug in our appliance. Don't try this at home unless you have a JBL Power Series BPX amplifier, a sturdy vise, and something to protect your eyes from flying debris. Good luck doing that with a conventional high current amplifier. Be sure to tune in next time for another episode of JBL Car Audio's What the